Everybody doing pretty well? Did you guys like the yesterday? You probably liked not having to come to school, but on the other hand, if you did that day after day after day after day, it gets old. It gets really old. So I'm glad we had a practice run, but I'm really, really glad. You guys are doing the right thing as far as right now. You must be doing the right thing as far as reporting your health, keeping your mask on. I could just, for right now, whether it works or not, something's working. You get that? So I thank you. Appreciate that. All right, so here's what we did. Here's what you saw in the video yesterday. And this is where you fill in gaps, right here. All right, we're going to try to name a few thousand compounds. Now, we're not going to actually do that. I'll just show you the pattern. You get it? And so let's do it type 1. Type 1? What do you mean type 1? Well, type 1 means what? What's binary mean? Only 2 elements, right? Okay, now, ionic. What does that mean? Metal and non-metal. And it has to be an always metal. And I went ahead and darkened that on the video yesterday so some of you can actually see it a little more visually. If you're an alkali metal, you're always, group 1A is +1, group 2A is always +2, and then there's 3 more: silver, zinc, aluminum, +1, +2, +3. It will not take you that long to remember they're always metals, would it? It's not that long, right? Okay, now, so then if I said, what is the name of this? The way you name it, and the metal's written first, you say calcium, but all binary compounds end in IDE. So I don't say calcium chlorine, I say calcium chloride. And it doesn't even matter whether there's 1 chlorine or 2 or 3 or whatever. For this type, we just say calcium chloride. What? That sounds pretty easy. That's right. That's why it's type 1. It's the easiest ones. Let's go the other way now. What if I tell you that's aluminum sulfide? Oh, IDE? I'll bet it's binary. I'll bet it starts with aluminum, and I'll bet it has sulfur in it. Is that right? So now, we think to ourselves, hey, aluminum, I know you. You're one of those always metals. You're +3. But what about sulfur? On the nonmetals, these are -1. What are these? -2, and right here, -3. That wasn't hard. I think I can do that. So the sulfur is -2, but all compounds have to have a net charge of 0. How am I going to make this be 0? Remember, one of the tricks I used is, what's the smallest number, and 3 and 2 both go into evenly? 6. So 2 times 3 is 6, and 3 times 2 is 6, right? So watch. If each aluminum is +3, and I had 2 of them, that's +6. And each sulfur is -2, and I have 3 of them, -6. Whoa, I got myself a compound there because the net charge is 0. Al2S3. The name again? Aluminum sulfide. Now, some of you are looking like this. Well, this is too easy. When's a hard thing? Well, maybe it won't be hard for you. All right. Now, let's go to type 2 now. Type 2, watch now. Oh, it's binary. It's just like type 1. It's ionic. That's like type 1. Except what? What's type 2? Now, I didn't do it, but God said, some of these metals, a lot of the metals, I'm going to let them have more than 1 charge. Not the always metals. The always metals, there's only one way to make sodium chloride, because there's only one way sodium is going to form a compound. And that's why you'd never see a Roman numeral with type 1. You'd never see a Roman numeral with the always metals. Look at me. You'd never see a Roman numeral with the always metals. But if you're not an always metal, you will see a Roman numeral, won't you? Oh, that's what that's about. So now here we go. See these two? What would you call them? Well, you're iron oxide. You're iron oxide. Well, how can they have the same name? Okay, so what we have to do is, if it's a type 2, we have to do a little more work. We have to do a little more work. Oxygen is -2 in a compound, is that correct? The whole thing has to be 0, so this iron by itself has to be +2. The Roman numeral is the charge on the metal. Charge on metal is 2, So now I'm going to call it iron 2, Roman numeral 2, oxide. Iron 2 oxide. Let's go down here. Each oxygen is -2. I have 3 of them. That's -6. You have to be +6. 2 times what equals +6 plus 3. What is each iron? Each iron is what? 3, isn't it? So I say iron, Roman numeral 3, oxide. Hey, I'm iron oxide. Hey, me too. I'm iron 2 oxide. I'm iron 3 oxide. Okay. Well, then you saw something that would have woken you up. Maybe it didn't wake you up. Could have put you to sleep. But yesterday on the video, you saw something I hadn't taught yet. And before they started using the Roman numerals to name compounds, a lot of scientists thought that metals only had 2 forms. You had this charge or this charge. And they used this thing called the Ich-Us system. Now, the Ich-Us system, that's what that weird drawing is on your handout sheet. See? I made that up. It's called a big, icky monster, right? The big, icky monster. Well, I'm here to tell you that I didn't do this, but God said, iron, sometimes I'm going to let you have a +2 charge, and sometimes you're going to have a +3 charge. Which one is bigger? Which one's bigger? See, 3 is bigger than 2, right? He's the big, icky monster. And look at copper. Copper can be +1 or +2. And I'll let you know. I'll tell you this on the periodic table. When you take your test, I'll even tell you that. Iron comes in +2 and +3. I'll tell you. I'll tell you copper comes in 1 and 2. I'll tell you. But who's the big, icky monster here? 2. 2 is bigger than 1, isn't it? Now, they also use the Latin form of the element. I'll let you know that. I'll put that on your periodic table. I'll say the Latin word for iron is ferrum. So you are the big, icky, ferric ion, and you're the ferrous ion. I'm looking at your faces. You have to tell me with your faces what's going on, okay? Yeah, I have to know what's going on. 3 is bigger than 2. The Latin word is ferrum, ferric, ferrous. Let's go back up here. Ready? 3, 2. You're the big, icky iron, aren't you? You're ferric, big, icky, ferric oxide. Notice that when you use the old system, they do not use Roman numerals. That's before they started using Roman numerals for this. So it's just called ferric oxide, and you must be the other one, ferrous oxide. Let's go with copper. Let's go with copper. Copper comes in 2 and 1. 2 is the big, icky monster, and cuprum is the Latin word. And I'll let you know. I'll put that on your periodic table. You don't have to even memorize it. Get it? Cuprum. All right? And now, they're cupric, and you're cuprous. So now, let's try this one. What if I said, name this compound here. Let's do this. Name this compound, CUS. Okay, I want somebody to name that compound for me, CUS. Okay, who wants to show off? Who thinks, I think I might have this down. All right, now I'm ready.
Copper, and then you put a space and then salt.
What Roman numeral do you want?
You put a space and then not copper sulfide, but
And you know, I've asked this for somebody in the last class, and they stopped and they said, I'm not really sure. And that's what I want to hear. Okay, so what do you think on the Roman numeral? Yeah, what's the charge on sulfur in a compound? Look up here. What is it?
-2.
Yeah. And all compounds have to have a net charge of 0, so this copper must have what charge?
2 +2.
And the Roman numeral is always what?
Copper 2.
Yes. Now, you're not done, Yao, because there's another way you could name it with the old naming system. And you know what? If the old naming system was not still used today, I wouldn't even teach it to you. Well, you're teaching you both methods here. It won't go away. The people in your college or professors, they're going to use both systems. If they told me today, we're not using that Ich-Us anymore, I'd stop teaching it. I can tell you right now, if I go to the catalog, and I order chemicals every year for chemistry, and if I don't know the other naming system, I won't know which one I'm getting. I know it's not going away. All right, so what's the other name? Yeah?
So it's gonna be, cupric.
He's the big icky copper, isn't he?
So it's gonna be cupric sulfate.
Cupric sulfate. Yeah, huh? I mean, not sulfide, I'm sorry. Did you say sulfide?
Yeah.
Okay. There you go. What do you think? Scary? That's scary? Not too bad. Not too bad. All right. What I'm going to do here, take a small break and get your homework. See your homework packet? Okay, let's take a look over here. Oh, shoot, this is already written on. Darn it. Hey, can I borrow yours? I'll even write the answers on it for you. Okay, now, I'm going to go to page 2 here. And when you watch the video, okay, you're going to help me, all right? When this right here, oh, wait, you can't do this yet. Sorry. Here, take that back. Okay, sorry, I can't take a break yet. I got reset here. Now, the next thing you saw yesterday was this. Dun, 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 dun. What happens, this is called type 3. What happens when it's not binary? What if it has 3 or more elements in it? Well, I have some good news for you. If it has 3 or more elements, number 1, it contains a polyatomic ion. That's good news. Now, good news number 2, somebody else has already named it and given it a charge. That's good news. Good news number 3, you will never change the name of a polyatomic ion. Never. Got that? So, if you were to look at your polyatomic ions, and you look at this, say, whoa, what? Whoa, there's one element. There's an, this is not binary. I must be looking, I'm going to go look for polyatomic ions. So you go over here, and you said, I found you. I found you, right there. Somebody already named you nitrate, and you're a -1 charge. And so, this isn't always metal, isn't it? I don't have to worry about doing any extra work. I don't have to worry about the charge. It is sodium. What's the name of this? Sodium nitrate. You said, wait, that was supposed to be hard. No, if you knew nitrate, you know it's called sodium nitrate. Yes? Okay. Now, let's go over here. I'm going to cover that up, okay? Let me cover that up. You can't see it. What are you going to call this chemical right there? How about that? Let's do, I'm going to call on, how about, Win, since I was going to call on you anyway. This is called what? What's that thing called? The NO3, what's it called? It's the same one, it's not a compound. Hey, can I tell you, I'm going to give you a question I always ask on a test. I'll even tell you what the question says. Ready? What do you call a group of elements chemically joined together whose net charge is 0? Everybody. Compound. What do you call a group of chemicals, atoms that are chemically bonded together, but their net charge is not 0? Polyatomic ion. I cannot call that a compound because it has a charge. You get that? And so, now, ready? Somebody named that. Do you remember what that name was? What is it? Hang on. Wynn's going to do this. This is nitrate, right? You'll never change the name of nitrate. Never. Now, this guy right here is copper. And is he an always metal? No, he's not. So that means I got to do a little extra work. And you're going to see me do this a lot, okay? How many nitrates do you see here? Don't say 3. Don't say it. How many nitrates do you see? 1. And each nitrate's a -1 charge, isn't it? There's only one of these guys, so what's the charge on this copper? All compounds have to have a net charge of, so if you're -1, I have to be +1. So what's the name of this guy? Boy, if he had been always metal, I would just say copper nitrate. But now I get a little extra work. Copper what?
Copper.
What's the Roman numeral going to be?
1.
Yes. See that? Copper 1 nitrate. Now, let me give you a hard question. The old naming system copper comes in 1 and 2, and the Latin word is cuprum. What's another name for copper 1 nitrate? Is copper 1 the big icky copper?
It would be cuprous or
Say it.
cuprous,
Cuprous what?
cuprous nitrate.
Yes. You didn't think you could do that. You did. You did it. Everybody ready? All right, let's do the next one. Olivia, what do you think for the next one? Look, that's pretty weird. Oh, what's this? What's this? Parentheses? What does that mean? How many nitrates are in this compound? How many nitrates are in this compound?
2.
That's right. Whatever's in that parentheses, I have 2 of them. Nitrate? I have 2 nitrates. Each nitrate's -1. You have 2 of them. That's -2. What's the charge on your copper then?
Plus 2.
Yes. So what's the name? The Roman numeral is always the charge on the metal.
Copper 2 nitrate.
Yes. Yeah, see? Hey, we're putting this together, you get it? We're putting things together today. Now, I have another name, Olivia. Another name. Copper comes in 1 and 2, and the Latin was cuprum. This looks like the big icky. 2 is bigger than 1, isn't it?
It would be cupric.
Cupric what?
2 or nitrate.
All right, remember, if you say cupric, don't also use the Roman numeral. Get that?
Oh, yeah.
So cupric nitrate. Woo! There's no way. When you walked in today, you probably didn't know that you would have to name that. You would have said sodium nitrooxide. See that? No? No, somebody's already named it polyatomic ion. Yeah, see that? All right. What do you think? Okay, now, can I borrow that paper again? Now, sorry. Now we're going to go back to this page right here. And I'm going to pick somebody else now. Who can I pick? How about Claire? Claire, you want to do the first one? I'd like you to do this one right here, number 3. And you can use the chart. There's a chart, either this chart or I know you haven't memorized these yet. I didn't expect anybody to have memorized yet. But what is SO4?
Sulfate.
So I know it's going to be sulfate. And I never changed the name of sulfate. I'm ready. So what are you going to call it?
Iron. Or wait.
What's the charge on sulfate?
-2.
-2. So the whole thing here, my fist, this whole thing has a -2 charge, doesn't it? But all compounds have to be 0. So what's the iron's charge?
2.
Okay, so what's your name?
Do you want?
The Roman numeral name.
Oh, okay.
It's called the stock naming system.
2 sulfate.
Yes, the Roman numeral is a charge on the metal, isn't it? Okay, now, I will tell you that iron comes in +2 and +3.
Ferrous sulfate.
Say it again?
Ferrous sulfate.
Yeah, he's not the big icky, so he's ferrous. You're right. You guys are catching on pretty fast. Okay. Has anybody heard of Ferris State University? No? Okay. You have? Have you been there? Okay.
Is it spelled F-E-R-O-U-S?
No, that's a good question. No,
F-E-R-O-U-S?
no, but a lot of the money that started that university came from where? Does anybody know? Came from, they were digging something out of the ground. Any ideas? Iron. Is that what you're going to say? Sorry. Iron. Okay. All right. So anyway, let's do another one, and I'll give this back to you after you do one more, okay? Claire Hagler, you're going to do, oh, look at that one. Oh, scary. That's a scary one. Okay, let's do number 10. Okay? before today's lesson, you might have said copper carbohydroxide, but no, we're not going to say that. So what is it? It's not binary, so go look for a polyatomic ion. Say again? Yeah, and what's the charge on acetate? All those atoms together have what charge? Yeah, so what's the charge on the copper? Yeah? All right, give me a name. Yes, acetate. Okay, and I'll tell you that copper comes in +1 and +2, and the Latin name is cuprum. All right, so what's the other name? Right. Now, did you understand that type 3 is not like a whole new animal? It's like the same kind of rules for type 1 and 2. Isn't that right? Except I have these things called polyatomic ions. It's kind of the same thing. Here you go, Win. Thank you for letting me do that. All right, so what do you think? What do you think about that? Not bad? Let's see if I have one more here. Let's see. I don't want to do that one yet. All right. So anyway, type 1, type 2, and type 3. That's how you do them. I will tell you one thing is, did you notice that when I wrote this one, I did not use parentheses around nitrate, and this one I did? That's another test question I always ask. The only time a parentheses is used when writing a formula is when you need more than one. Victoria, help me out. The only time a parentheses is used when writing a chemical formula if you need more than one. Okay, what is it? You don't know? Not sure? That's all right. That's fine. Todd? Polyatomic ion. See, I needed 2 nitrates. That's why I had to put in parentheses. How many nitrates are here? Don't say 3. 1. There's 1 nitrate. You get it? I'm looking at your faces. You look like you're doing pretty well. Okay? All right. Are you okay with this? All right. So what I'm going to do now is let me give you one more. How about it? Let's do one more. And if you can get this right, then I think we're ready to do something else. Okay. Okay, tin comes in 2 forms, +2 and +4. And I'll tell you that on the test. You don't even have to memorize that. You get that? And the Latin word for tin is stannum. No wonder the symbol is SN. All right. Kieran, I think you can do it, right? You're going to show off. You're going to tell people both names for this compound. So I'm ready. You teach it to me, all right? How do you do this? For tin? Tin is the name of the element. Tin, Tin.
Oh, I thought it was standard.
Well, that's a Latin name.
Oh, okay. It's had a charge like -2, or no, +2.
What does oxygen have in a compound? What is oxygen in a compound? Say what?
-2.
Yeah. And how many oxygens do you have?
2.
That'd be -4.
So you need 2 and
No, I don't have 2 of these. I only have 1 of those.
wait.
So if this whole section here is -4, then what does this have to be? All compounds have a net charge of 0. Each oxygen is -2, but you had 2 oxygens.
+4. So
Yes.
+4.
Yes. So I'm ready.
So it's
Tin.
10 oxide, or no, 10.
You would have been right if it had been always metal. The Roman numeral is always,
10,
yes. The Roman numeral is always the charge on the metal. Is that right? No, you're almost there. One more. What's the other name? The us name.
Stan, or no, Stan.
See the big icky? Is he the big icky?
Yes.
Okay, I'm ready.
Stannocks.
Yeah, that's it. What do you think? Yes.
So with gold, does gold also have the same two different forms?
Even though I don't have you memorize those, I can look up here, and this says gold is 1 and 3. I'm not going to have you memorize that, but if I did, I would tell you gold comes in 1 and 3. 3 is a big icky monster, and the Latin word is aurum, A-U-R-U-M. And so you have auric or auras.
So you have an Oros and an Oric.
Uh-huh.
Alright. So the ones we need to know that have like different names would be tin, copper, iron, and gold.
And again, I would let you know, you're right, the one, I always use iron and copper all the time in chemistry. The other ones were lead. Lead is plumbum, and you don't have to memorize that because I'll let you know that. I'll write it on the periodic table. Plumbum. See why is the symbol for lead Pb? The Latin word is plumbum, right? So you have plumbus and plumbic. There's actually mercuric, mercurus.
But we wouldn't use mercurus, mercury, right? That's not-
They actually didn't use the Latin. They actually didn't use the Latin for that. Maybe because it's hard to say the name anyway. I only know I don't even know it. So I don't. And the Latin word for it, they don't use for some reason.
We wouldn't have to use mercurus, mercury, right? Because mercury is not going to be used in the type 2 binary compound.
Mercury is an exception, and I'd like to teach the exception when I'm all done with this.
Okay.
And do you know about mercury?
Not exactly.
Okay, so mercury is an exception to the rule, and I'm going to teach that at the very end. So if I can get you to understand type 1, 2, and 3 right now, you're way ahead of the game. Okay? You just make sure you understand 1, 2, and 3, and then 4 and 5 are different, and they don't take that long. Okay, so here's what I'll do is, let's see. Okay, here's one. On this page, and this is where you gotta be careful with. I've seen this every year. When I give this test, I've had people that when I write the formula for them, they're pretty good at naming it. But guess what the other half of the test is? It's where I give you the name and you have to write the formula. So you can't tell yourself I'm only can go one way. So let's try one that looks kind of harder. How about number 10? Let's do number 10. Lead 4 chromate. Okay, lead 4 chromate. All right, so we know lead is Pb. All right.
What page is this?
It says 48, so whatever that means.
Oh, there. Okay. Gotcha.
Lead 4 chromate. Now, it doesn't end in IDE, so I know it must be a polyatomic ion guy, right? And does anybody happen? I doubt whether you have memorized chromate yet, but can you look at your flashcards or look at
0.04.
CR what?
0.04.
But what's the charge on chromate?
-2.
-2. But guess what? They told me that this lead was what?
4. Change
Ah.
to chromates.
Wait a minute. If that lead's 4 and chromate's -2, that's not going to work. All right, Will, what am I going to do here? If the lead's 4 and the chromate's -2, what am I going to have to do here?
Put the CR4 in a parentheses and then do a subscript.
Very nice. Very, very nice. I'm going to have 2 chromates, aren't I? Does that make sense to you? Each chromate's -2. I have 2 of them. That's -4. Very, very good. You okay with that? Honestly, if you can do type 1, 2, and 3, like I said, I really want you to do. I can teach you type 4 and 5. Matter of fact, I can teach you type 5 in less than 5 minutes. I'm not worried about type 5. Type 4 will take about 10 minutes. I'm not worried that much about those. I really want you to know type 1, 2, and 3 really, really well. Now, last thing I want to do is I want to show you one way that might help you start to memorize your polyatomic ions, okay? Now, even though I did it on the video, I'll bet it was, I'll bet you may not have gotten a lot out of that, because I went too fast, I don't know, but let me show you, how many are there, by the way? How many, did anybody count them? I can count them. How many?
25.
25, really? Okay, 25, you're right. Okay, these will be later. I'll teach these to you later. They're exceptions. Okay, so there will be eventually a little bit more than 25, but not too much. All right, how in the world do I start memorizing these? And what I did was the ones that were the famous eights, if you could start and just start with that and say, I think I could do 8 of those. Can I remember that chlorate has chlorine in it? Even permanganate has manganese in it, doesn't it? Chromate has chromium in it. Carbonate has carbon in it. Sulfate has sulfur in it. Phosphate has phosphorus in it. I might be able to do that. Let me tell you what, if you can somehow memorize those famous 8, I'm going to help you a little bit. So that's 8 down. 8 down. Check. Okay. Now watch. If PO4 with a -3 charge is phosphate, if I take away an oxygen, they're going to call it George. No, they said that would be stupid. So if this was phosphate, they're going to call PO3 phosphite. Oh, so if you know phosphate, PO4, you know phosphite, PO3. Okay, now, next. If you know phosphate is -3, what do you think would happen if I tack on a +1 hydrogen? It used to be +3 phosphate. I'm going to tack on a +1 hydrogen. Now you can't be +3 anymore. You got to be, I'm not -3 anymore. You got to be -2. Is that right? And we'll call you Jerry. No, let's not call you Jerry. Let's call you what? Hydrogen phosphate. Thanks. Thanks. So if you know phosphate, you know phosphite. If you know phosphate, you know. Let's do it again. That's fun. Let me tack on another hydrogen. Now you can't be -2. You have to be -1. Bobby? No, not Bobby. What are you going to call it? Dihydrogen phosphate. One more time. If you know phosphate, you know phosphite. If you know phosphate, you know hydrogen phosphate. If you know hydrogen phosphate, you know dihydrogen phosphate. They didn't even put these on there, but what is hydrogen phosphite? What's hydrogen phosphite?
HPO3.
What's dihydrogen phosphite?
H2PO3.
See, I got it. Let's go down here. Let's go to sulfate. Sulfate is SO4. I wish all the 8s are O4, but they're not. Phosphate's O4. Sulfate's O4. Get it? But- but not nitrate. Anyway, if you know sulfate is SO4 -2, what is SO3? The good news has the same charge. But not sulfate, but what? Sulfite. Oh, I get it. Now, what if you know sulfate, you know sulfite? If you know sulfate, let's tack on a +1 hydrogen onto you. You used to be -2, but you can't be -2 anymore. You'll be -1. Sulfate, sulfite. Sulfate, hydrogen sulfate. What if you tack a hydrogen onto sulfite? Hydrogen sulfite. Huh. Are you with me? Are you with me? Eventually, you're going to see some patterns. Okay, now, this one, carbonate, the good news, the only carbonite is on Star Wars. Remember Han Solo got locked up in carbonite? And there's a company that will protect your computers for $55 a year. They're called Carbonite. But there's no carbonite in chemistry as of right now. So there is carbonate, no carbonite. But what if you tacked on a hydrogen on a carbonate? What would that be? Hydrogen carbonate. Okay. Did you know the old name for that is bicarbonate? I didn't do it. But if you go home tonight and you get a pack, say, Mom, Dad, you have any baking soda? Yeah, here's a box. Everybody has baking soda, probably. Look on the side. Contains sodium bicarbonate. What's bicarbonate? Hydrogen carbonate. Oh, okay. Let's go down here. Chlorate has chlorine in it, doesn't it? If chlorate's ClO3, sorry, it's not O4. If chlorate's ClO3, what if you take away an oxygen? What would you call it? Chlorite. Huh. And this is what I did on the video. This is a whole series. I'm going to learn these all together. All right, let's say I know the famous 8 chlorate. Get it? Take away an oxygen, what are you going to call it? Chlorite. Now, they could have called this, take away another oxygen. They could have called it chlorite, but even a human would say, I'm not saying that. I'm not saying sodium chlorite. I'm not doing that. And so they said, I use a Latin word. Hypo means less than, below. Isn't that right? Hypo. Hypothermia means you're outside so long, your body temperature is lower than it should be, right? It's colder than it should be. So they call it hypochlorite. If you know chlorate, take away an oxygen, you have chlorite. You take away another oxygen, that's even lower than chlorite. That's hypochlorite. You go home and be very careful. If you have some bleach in your laundry room, it'll say contains sodium hypochlorite. That's what bleach is. Sodium hypochlorite. Now, the only thing I don't like, if I know chlorate, what happens in chemistry if you want to add an oxygen onto it? Did you know that this is called water? Or you could call it hydrogen oxide? But then this, I would drink that. I would not drink this. What? Right? What was H2O2? Anybody know what this is? No? Two chemists go into the chemistry bar and restaurant, and the person says, man, it's really hot out. Says, oh, I'll have some H2O, because this is a chemistry bar and you know what that is. And the other guy says, I'll have some H2O too. And one of them dies because he asked for H2O2. That's hydrogen peroxide. So anyway, what happens in chemistry if you want to add oxygen? You say per. And so this is chlorate. This is what? Perchlorate. Oh, okay. Good news, they all have the same charge. Isn't that nice? And I have one more that I'll help you with. Somebody should have woken somebody up at night, slapped him in the face, and said, how dare you name this polyatomic ion? What is the name of that polyatomic ion? Hydroxide. You should not have done that. You know that IDE means that it's a compound with only 2 elements. Shame on you for naming a polyatomic ion that, because now, what do I have to say for this guy? He's not binary, but what do you have to call him? Sodium hydroxide. Slap, 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 slap. You shouldn't have done that. And there's one other one that was named bad, poorly. What's that one called? And if you go get some rat poison, it'll say contains sodium cyanide. I remember those two because you should not have had those polyatomic end in IDE. Shame on you.